So here's basically what we talked about. If I have x raised to the 1/2, remember last time I showed you that this is the same thing as the square root of x. Okay, understanding what is this number right here, even though it's not there? It's a 2. We're looking for the square root, hence there is a 2 there, right? What is the power on x? 1, right? So therefore, if I had a generic case, if I had a raised to the b divided by c power, okay, what would that be in radical form? The c root, okay, not everything's a square root. A raised to the b. Okay, everybody understand that? That is a big deal today. Okay? So, if I gave you this, somebody tell me what would that be in radical? If it's in radical, what would it be in rational form? Yes, sir. It would be 4 to the 1/3. Is there another way I could write this? What's another way I could write 4? 2 squared, right? Isn't 4 the same thing as 2 squared? So this is the cube root of 4, of 2 squared. What is that going to be? 2 to the 2/3. That'd be another way to write it, correct? And that should make sense, because notice here the same thing. I could write 2 as 2 squared raised to the 1/3. And what do I do on a power to a power? Add. I multiply, right? And what is 2 times a third? 2/3, correct? Everybody there with me? You see how those guys are equivalent? Okay, there's another way I could write this as well. Okay, you could write it as, so for example on this guy right here, you can write him as 2 to the 1/3 raised to the 2nd power. Because once again, power to a power, what would that be? 2/3, right? Okay, so this power right here can actually come out to be the outside power if you needed it to be. Okay, once again, guys, this is your learning, your understanding. So if you don't get it, please don't hesitate to ask, please. Yes, ma'am. So basically, 2 times 1 is the 2, right? So I just go ahead and think, okay, anytime I see a cube root, I think of the 1/3 power automatically. And then that power, whatever's in here, could go outside. Okay, so for example, let me show you what I mean on the next one here. If I had like 5 to the 3rd, very radical, isn't it? To the 4th. Right there, I see 4th root, right? So therefore I go 5 to the 4th. Raised to the 3rd power. Exactly. Okay? Or another way, I'm just trying to show you ways that we've seen them through math, okay? Another way is sometimes they'll have it like, how do I have it? I'm trying to lost it. Oh, I could have the 4th root of 5 cubed, and that kind of makes sense going exactly right to there, doesn't it? Poke in the back, does that help you? Okay, and that's this cube. So that power can come outside of the radical as well. Just come right here. Does that answer your question? Rich. I'm just showing you different ways that it has been known to be written. Okay? I wouldn't do that personally. I'm just showing you what could be written so that you've actually seen it, so if you ever do see it, you can understand what you're using. Okay? Do we have a question yet? You doing okay? Okay. On a square root, when we've done a square root before, such as the square root of 25, what is the square root of 25? Why is it 5 there? Not just because somebody told you. It is, exactly. Because there's an itty-bitty 2 there. That means we are looking for groups of 2, aren't we? Not the number 2, but a pair. Correct? Okay, and notice 25 is 5 times 5. So therefore, there is a group of 2, isn't there? And so that is the answer. So what if I asked you what is the square root of 100? Not 100. Do 200. It is not 100, because 100 plus 100 is 200, but that's not times it, huh? So once again, I can break it down. What's 200? 2 times 100, correct? But what's 100? Not 50. You keep adding, Mitch. 10 and 10. Notice there's my group of 2, right? He gets to come outside. I had a group of 2. Does this guy have a buddy to get outside of the radical? So he has to stay underneath. Okay? My analogy is like getting into a gel cell. The radical is a gel cell. For you to escape gel, you got to have a buddy. And when you get out, one of you gets shot. That's why we went from 2 to 1. Got to have a buddy to get out, but when one of you gets out, one of you gets shot. This guy just said, screw you, I'm staying in jail. Okay? He didn't want to find a buddy. I don't know if that helps. My little analogy. Yes, ma'am. You're more than welcome. Yes, sir. So 10 root 2 is the same thing as square root of 200. Because what is the square root of 100? And then we don't know what the square root of 2 is. Because we can always break down also, I don't know if you guys learned this previously, but square root of 200 is the same thing as square root of 100 square root of 2. Anything that is multiplied underneath radicals will stay there, right? So therefore 100 times 2 is 200. The square root of 110 square root of 2. That's a better visual as well. Okay, so then if I am looking for a cube root of, let's say, 64. What is the cube root of 64? So therefore, I'm not looking for pairs this time. I'm looking for triplets, right? Does that make sense? Group of 3 this time. Yes, no? If I have a 100th root, what are you going to be looking for? Group of 100, correct? Everybody there? Understand that? Okay, so we're going to break it down. Can anybody tell me what is 64? What numbers make up 64? Okay, we have 8 and 8, somebody said. Somebody also said 4 and 16. That was a little bit nicer, but we can get the answer the same way. Notice what's 16 here. And then notice we have our triplet, don't we? So what is the cube root of 64? 4, right? But let's say you didn't know 4 times 16 was 64. You knew 8 times 8. Can I still get there? Sure, watch. Here we go. 2 and 4. 4 and 2. 2 and 2. 2 and 2. Look, a group of 3. A group of 3. So they both get to get out, don't they? So a 2 times a 2 is still 4. So even if you didn't know 4 times 16, can you still get there by breaking it down into prime factorization? Does everybody understand what prime factorization is? Meaning you just break it down into numbers that are prime. Right? You can't go into them anymore. Okay? Does everybody understand that? Once again, if there's somebody left over that you can't break down, leave them in there. They got left behind. Okay? Let's see. therefore, once again, okay, going back onto there, Ridge, I had a group of 4, like 3 of them, right? So what is the cube root? You're looking for that group of 3, which is 4. And then here I had a group of 3, which was 2, and another group of 3, which was 2, right? But what is 2 times 2? Because they all get outside of the gel cell. If you think about it, this is, once again, my analogy. You don't have to like it, but this is my analogy. The more, like the cube root, 4 through, it's more intense prison. You need more people to help you get out, right? So once you get out, you can go ahead and multiply together and have good times. You with me on that, Ridge? Because you've been in jail. All right. Okay. So now I'm going to ask you to go ahead and write this as a radical. Okay, anybody want to help me on this, please? Okay, so we are in rational form. We are moving to radical form. Okay, rational to radical. If you want to give it a shot, please help me. Come on now. Hogan, you'll give it a shot? So square root here, that's because of the 2. But it'd just be 24x, I think is the way you were saying. Is this correct? Hogan, thank you for trying. This is not. Can anybody tell me why? Is 24 being raised to the 1/2 power? No. Who is being raised to the 1/2 power? X. Hogan, if it looked like this, then you would be correct. Does everybody understand that? Because 24 is being raised to what power? 1. X is being raised to the 1/2 power, right? Okay, so if this was parenthesis 24x raised to the 1/2, Hogan would have been correct. And I appreciate you giving it a shot. Thank you. Okay, that would be correct, but that's not what we started with. We started with this. Hogan, I'm going to give you another shot. So does he go underneath the radical? No, he stays outside, huh? Work with this for me. What radical would it be? Square root again, right? And what power on the x? 1. Right there. 2. Everybody understand that? You see the difference between a parenthesis and a non-parenthesis. That is something a lot of students struggle with. Okay? So once again, the final answer of this of 24x to the 1/2 would be 24 square root of x. Yes, ma'am. It's because you don't have to. Do we really own a square root? Do we really need to put that 2 there? No, but if it was a cube root, do I need to put a little 3 there? Sure. I'm just showing you where it came. Does that make sense to you? Yes, Jackson, right? Surely can. You want one with parentheses or just something like I just barely have? Alright. I'm going to do one like this. How about that, Jackson? Can you help me on that one? Okay, so what's the power on 8? I'm going to let you help me. It's okay, I promise. Just help me out. I'll help you with me helping. Fair deal? What's this power right here? Okay, so therefore he's already here. He doesn't need to go underneath the radical because he is a he is a fraction technically, but he's not in a simplified fraction. Oh, hell, how do I want to say this? This guy's already, like, I can't reduce him anymore, right? He's in a fraction, that's where it's going to be. This guy's going to stay out because he's not having a non-reduced hell, I don't know. Hopefully you get what I'm saying. Does everybody get what I'm saying? How it's a whole number? It's a whole number. That's what I'm looking for. This is a whole number. That's why he doesn't have to go under, right? Is 2/3 a whole number? No, he is a fraction, so therefore we're going to split him up. Okay? So I have the 8. He gets to stay outside. Good with that? Everybody good with that? Okay. What radical is this going to be? Because my denominator is 3, that is a cube root. Are you okay with that, Jackson? Everybody good with that? Okay, and then what's going to go underneath? X squared. Okay? You guys think we can do that? Okay, now notice, let's see, what if we had, yes, Rick? With a negative exponent, I don't think we're going to get to negative exponents with rationals today in my denominator because we have to do something called rationalizing, and I don't believe we're quite ready for rationalizing when we do that, to be honest. Okay? So I don't really kind of want to introduce it until we go the full extent. Because technically, if that was the case, you'd jump him down, right? Correct? And you still do the same thing, cube root of x squared. But in math, that is not simplified. That makes me cringe to see this. You guys might be like, that looks fine to me, right? But in the mathematical world, this is a non-simplified answer. So, and I don't have time to share what we do with this quite yet. Okay? Does that answer your question? Okay. So, let's say we had 27a raised to the 2/3. I'd like you to simplify this the best you can. Okay, so this time it has parentheses. So that means 27 is being raised to the 2/3, as is a. Does everybody get that? Carlos, you with me? I'm going to ask you honestly, Carlos, if you didn't have that headband in, would your hair fall in your eyes? You really think it would? No, it's all right. Okay, what's going to be my radical? Say again? Is that my radical? The radical is like the root looking thing, by the way. Cube root, right? Okay. By the way, square root, cube root, they have the cool names. Anything higher than that, we call it whatever root, right? 4th root, 5th root, 6th root. Get the idea. 13th root, 100th root. Okay. Where do people go? And this is the time, like I was telling you, to rewrite it different ways. I am going to put the squared out here. Here's my reasoning. Okay? There's a number underneath there. This time, let's go ahead and try it. Okay? Right, Misty? Huh? Did I say, go by Misty, right? No, never mind. Micaiah. Never mind. That was a different person. I apologize. Sit in the same seat. I got you now. I apologize. Okay. Okay, so it's a cube root, so we're going to look for 27 to have a group of 3. Do you guys think it has a group of 3? It does. What's in 27? 3 and 9. And what's in? That's a bad 9. Did you say just straight out 3? And there's your group of 3, right? Everybody with me on that? So who gets to come out? Does A get to come out? No, he still stays under. So now I'm at 3 cube root of A squared. Does that make sense? You okay with that? Or did I lose you if that was the case?
That whole thing.
Okay, because once again, a cube root means you're looking for groups of 3, right? Or not like the number 3, but a triple.
Yeah.
So I break him down. 3 times 9. 9's not all the way broken down. That's 3 times 3. Look, there's a triple. So if you have a triple with a cube root, that number gets to come outside of the radical. right?
Yeah.
A's all by himself, he can't get out. Okay, from here to here?
Yeah.
And then the parentheses were already squared, so hence I still have the parentheses squared. You with me? Maddie, no. Just keep him in there. Yep. Yes, sir. Oh, for a regular square root? No. If it helps you, you're more than welcome. But I'm just now, we should understand that anytime we see a square root, that is a little too out there, right? Yes.
If we did that, like, not the full answer, if we did the other one, would we get punished by that?
If it was worth 4, I might give you 1. Okay. All right. We're not quite done yet, because now I got to bring in my power. He's going to go into there, and he's going to go into here. So what is 3 squared? 9. Does everybody understand that? Okay. Now remember, as I just showed you previously, okay, in the past couple of slides ago, remember I had you do that and say the cube root of a squared was the same thing as what? A to the what power? 2/3, right? You guys remember that? Okay, so this is 9 cube root of a squared, or depending on if they want it in radical form or rational. Not quite sure what they want. They might tell you what they want on the test, right? They might want it in rational form. Is this in rational? This is radical. So what would it be in rational? 9 raised to the a raised to, a raised to the 2/3. Okay, makes sense? Depends on what they ask. If it's radical, it's this one. If it's rational, we go with that guy. Does that make sense to you? The 3, once again, comes from the cube root. Is that okay with you, Carlos? Say what? Rational. Okay. So now, what we're going to do is I'm going to put it in a radical. So let's say I have 256 a to the 8 underneath the 4th root. Somebody help me out and tell me what would this be as a rational exponent? How would I write this as a rational exponent? Good. 256 a to the 8 raised to what? You had it. Keep going. The 4th. 1/4, right? That's what you mean by the 4th, right? That's it. Pretty simple, huh? Okay. Everybody got that on there? Can I go to the next slide? Hold on, we'll wait. I see some people studying it a little bit. That is rational form. Radical is when you have like the root over it. Yes, sir.
Is the 1 on the 1/4 from the...
Because technically, this guy is technically raised to 3. Because what's 1 times 8? 1 times 1, 1. So it's whatever's underneath raised to the first one. Now, if I brought him in, this would be 256 to the 1/4 a squared. Because this guy's got a power of 1, right? So I could individually do them as well. 256 to the 1/4. 8 over 4 is 2. Yes, ma'am. Yes, ma'am. Changing it from radical to rational. Has anybody seen radical to rational before, except for the stuff I showed you just a skidgeny yesterday? You have seen it before? Yes. Because it's not 256 is not being raised to the 8th power. True? That's once again, if it was, you'd have like this. You gotta believe in your parentheses, right? Who was raised to the 8th? That's not what it looked like. Who was being raised to the 8th power? A, not 256. Does that answer your question? Because I think you were saying, well, if this is raised to the 8th and you just divide it by 4, why don't I just write it to the 2nd power? That's what I think you were saying, but the whole thing underneath wasn't being raised to the 8th power. Okay? Only A was. So that's why I'm saying there's multiple ways I could write it like this, or I could have it this. And technically, 256 to the 4th is 4. Just slightly. There's 4 4s in 256. Okay? Yes, no, maybe so? Okay. So, now, I'm going to have you do this. If I have b squared times b to the 2/3, I would like you to put your final answer. I want you to simplify. Then, in radical form. That is my goal. Simplify, then in radical form. So, this is exactly like yesterday's, right? What are we going to do when we have like bases with exponents? Hopefully this is day 4. We can do it. Yes, sir. We add them, right? Go ahead and add them. Okay? So we're going to go 2 plus 2/3, which is 2 2/3, correct? Do I want to see it this way, though? No. So then we go from this mixed number to an improper by quickly just going 3 times 2, 6, 6 plus 2, 8/3. So this is b raised to the 8/3. Okay, that is simplified now. Are we in, though, radical form? Nope, we're not. Yes, ma'am. Yep, b to the 8th underneath the cube root there, right? And that would be our final answer. Pretty simple. Just to let you know, once again, I could have done this way, 2 over 1 plus 2/3. Once again, I need to get a what? Common denominator, right? So I times 3 top and bottom to get 6/3 plus 2/3, which is once again still our 8/3. Okay? You okay? You look a little tired still. Alright. See if I got anything else. Just 30. We got stuff to do, brother. We got a lot of fun. We could just pin homework stuff. And be pretty tired. True. True, but if you don't, it might need some more practice. You wish, right? Okay. That's not 1/4 area. Okay. I want you to simplify that as far as possible. No! I'm telling Bill that. I don't want you to be squeaky here. You're learning. Okay, so once again, we're going to break him underneath. This is the same thing as the cube root of 27a, right? Taylor, you told me the other time, what is the cube root of 27? 3, right? So I still have him. Is that everybody okay with that? Because if I break down 27, that would have the 3 3s. We've already done that previously, right? You okay with that? Haven't we already broke down the 64 as well? And what was the cube root of 64? 4, right? So, by the way, that'd be the cube root of 64a. So then I got 4 cube root of a. Is everybody there with me? Do we have a question there? Okay, what do we do with these? Yeah, we multiply. This is multiplying. So I go 4 times 3. Good job, Michael. And then notice, like I said last time, remember when I broke down 200, square root of 200? How I said that was root 2 times root 100? If they are like radicals, I can multiply the things underneath them. Does that make sense? Are these like radicals? So can I multiply the things underneath them? Sure I can. So what's a times a? A squared. So that would be the cube root of a squared. And that makes sense as well, because if you think about this as a rational, a to the 1/3, a to the 1/3. What's 1/3 plus 1/3? 2/3. Right? That makes sense? If they want it as a rational, I'd go 12a to the 2/3. Yes, sir.
Not combine them and say like, oh, if there was 3 of them, you combine them and then have.
Just have a single a. Because that would reduce down to 3/3, which is just 1, right? Okay. Feel comfy? Are you guys still doing okay? Once again, guys, please take your learning when you talk to me, you understand, don't be hesitant.